Hello, this is Mr. Mabrey, and you are watching a video about the water phase change demo. You should have just done an experience where you looked at a hot plate right here with some ice cubes in the middle that was boiling because of the heat coming up from the hot plate. And so you should have drawn a nice picture right here. Should have circled solid, liquid, and gas because all three states were present. And I hope you wrote for number 3 the water was undergoing a physical change, because even though the water was in ice, or it was in a liquid, or it was in the air, that water was still water, which would have been the best answer here. So I'm going to go ahead and write that in. It was a physical change because regardless of whether we're talking about the ice cube or the liquid water or the water, water vapor in the air, water is still water. Great. Now, as far as this picture, I'm hoping you said when an ice cube goes from here to liquid water that this was melting, and then from liquid water to water vapor that was evaporating, though I know it's really steaming because of heat, but let's pretend it's evaporating. And that from steam cooling to liquid water would be condensation, and from liquid water to an ice cube is freezing, which means process of elimination would tell us that going from ice cube straight to in the air is something crazy called sublimation. So assuming we got all that right, I just want to mention a couple more things that we're going to write down right here. First, I think it's important to note, go ahead and write with me, that substances change phases at a variety of temperatures. Now I suppose, let's be honest, it's not really variety, but it's at a range of temperatures. What I mean by that is water starts to both melt and freeze at 0 degrees, but as you get closer to 0, you're going to see things start to freeze. And even as you come from freezing to 0 and a little bit past 0, there's still be some stuff that'll be frozen at 1 degree or 2 degree or 3 degree, but it starts melting. So remember, there's a little bit of a range there. It's not a set point. It's not like instantly when the water cup in my hand hits 0 degrees, like poof, it's all ice. So there's a range to remember. And let's come down here and we're going to write melting and boiling points vary for different substances. For example, do you guys remember when we did that stations activity in the science lab and we looked at the sugar that was being melted into caramel? Well, sugar's melting point is 146 degrees Celsius. So that's quite a bit different from water. And if you're wondering, iron melting point is 1,535 degrees Celsius. Not 25, 35. So this is sort of obvious to us when we sit and think about it, but I know sort of in the heat of things in science, sometimes we forget that we could sit all day and put an iron bar underneath that hot plate, but it wouldn't do anything because it doesn't get hot enough. But when we put that sugar on the aluminum pie pan underneath the hot plate, it didn't. The aluminum didn't melt because its melting point was a lot higher than that of sugar, but the sugar's melting point was low enough that the heat from the hot plate was enough to make it caramelize. So remember these things as we go out through this week about phase changes. Make sure you learn this vocabulary right here for your quiz. That's definitely going to be on your quiz coming up. And I think you guys will be good to go. There you are.